Welcome to Twinkling online classes. In the last class, we completed the concept of the apparent depth and apparent shift. So, what is the formula we derived for the apparent depth means H apparent is equal to we derived H apparent is equal to H by mu, where mu is a what? Relative refractive index. Next, apparent shift is also we calculated H shift is equal to apparent shift is equal to we derived H into 1 minus 1 by mu. So, that is the concept of the apparent depth and apparent shift what we completed in the last class. So, in this today lecture we are going to discuss about the concept of the lateral shift. Lateral shift. So, what is the lateral shift? When we observed the lateral shift phenomena means whenever the light is incident on transparent medium, we will find the phenomena of the what? Lateral shift. So, when we identify the phenomena of the lateral shift means whenever the light rays are incidenting on the transparent slabs, transparent mediums, in that case only we will identify the concept of lateral shift. So that to explain the concept of the lateral shift, here I consider one glass slab. Which type of slab we consider here? We consider a transparent glass slab. Transparent glass slab whose thickness is equal to small t, whose thickness is equal to what? Small t, and its refractive index value is equal to what? Small mu. So here which type of medium we consider here? To explain the concept of the lateral shift, here we consider one rectangular glass slab, whose thickness value is equal to t and the refractive index value is equal to what? Mu. Now, what is the phenomena we are going to explain lateral shift? For that case, what we consider here? We consider an incidental light ray. We consider what? Incidental light ray. So, whenever the incidental light ray will be incidenting on the transparent glass slab, whenever the light was incidenting on the transparent glass slab, so which phenomena was takes place? Refraction phenomena was takes place. Why? Here, initially the light is coming from where? Air medium. Initially the light is coming from which medium? Air medium. So that the light will be traveling from the air medium to the glass medium, that is one medium to the another medium. Refraction phenomena will be takes place. So whenever the light is undergoing the refraction phenomena, we know that the path of the light will be deviates. The path of the light will be deviates. So if you observe in this diagram, initially we are assuming that along the path of the incidental light ray, there is no glass slab was placed. So, whenever there is no glass slab will be placed, according to the property of the rectilinear propagation of the light will be traveling along the straight line, so that the incidental light ray will be traveling along this dotted path. Whenever there is no glass slab was kept in the path of the incidental light ray, the light ray will be traveling along this dotted path. But we kept a glass slab in the path of the incident light ray, so that here the light ray will be undergoing the phenomena of the refraction. In this case, the light ray will be undergoing the refraction at two different points. First one is what? Whenever the light ray will be incidenting on the slab over the first refracting surface, here A dash B dash will be taken as the first refracting surface of the glass slab. So, whenever the incidental light will be incident at the point O, the first refraction takes place. So, whenever the light undergoes the refraction, it was bent, so that this light ray will be bended. Towards the normal. This point also we discuss. Whenever the light is traveling from the rarer medium to the denser medium, refracted light ray will be bending. Towards the normal. So that from this initial path towards the normal, the light ray was bent. So here the ray O2P will be calling as what? Refracted light ray. So here what we consider here, initially we assume AO is the incident ray. Whenever the incident light will be incidenting on the refracting surface, refraction takes place. So that here O2P will be indicating what? Refracted ray which was present within the glass slab. Once again, if you observe the diagram, because of it is a transparent medium, so that the whatever the refracted light ray we got O2P, that is again incident on the another refracting surface C2D. The refracted light ray which was present within the glass slab was again incident on the another refracting surface of C2D. So whenever this refracted light ray will be incident over the surface of the CD, secondary refraction takes place, so that the secondary refraction will be takes place where at the point P, so that the outcoming light ray will be calling as emergent ray. The outcoming light ray will be calling as a what? Emergent ray. This emergent ray is also existed where? In the air medium. If you observe, the incident light ray will be present in the air medium and the emergent light ray is also present in the air medium, so that the initial path of the incident light ray and these emergent light rays are both are parallel to each other. Which light rays are parallel to each other? The incident light ray as well as the emergent light ray which is coming out of the glass slab. These two light rays will be parallel to each other. So whenever these two light rays are parallel to each other, so here we will draw a perpendicular to the emergent light ray. So here this will be taken as PQ. So what is the PQ? The perpendicular distance of separation. What is this? Perpendicular distance of separation between the incident light ray and emergent ray. The perpendicular distance of separation between incident light ray and emergent light ray will be calling as lateral shift. So what is the definition of the lateral shift? Here the lateral shift will be represented by what? PQ from the diagram. From the diagram, P to Q will be calling as what? Lateral shift. How can we define? The perpendicular distance of separation. The perpendicular distance of separation between incident light ray and emergent ray is called as the lateral shift. So that is the actual definition of the lateral shift. Once again see the definition. What is the lateral shift definition? The perpendicular distance of separation between the incidental light ray and emergent ray. Will be calling as lateral shift. Now we are going to calculate the lateral shift value from the derivation. Okay. So now we are going to derive the expression for what? PQ. So here we are assuming that the perpendicular distance of separation between the incident light ray and the emergent ray will be taken as x. Now I am going to calculate the value of x. See, for this we are assuming that the angle of incidence value is equal to what? I. The angle of incidence value is equal to what? I, and the angle of refraction is equal to R. I will be assuming as a what? Angle of incidence, and R is a what? Angle of refraction. So here I will make one more triangle. Now first we will see the triangle. So let OPQ, this will be taken as a what? R. Now first we will see the triangle OPQ. So why we are taking the triangle OPQ means we are going to calculate the value of x. So here if this angle is equal to R, this angle is nothing but angle of deviation. That value is equal to I minus R. Already we told, whenever the light is traveling from the rarer medium to the denser medium, angle of deviation value is equal to what? I minus R. What is the angle of deviation? The angle between the incident light ray and the refracted light ray will be taken as a what? Angle of deviation. Now, which triangle I consider here? I consider the triangle OPQ. Which triangle I consider? Triangle OPQ. See here, from the triangle OPQ, I will took sin theta value, sin of I minus R, For the triangle OPQ, here O2P O2P will be the hypotenuse. O2P will be the hypotenuse. So that from the triangle OPQ, I am taking the value of sin theta value. Sin theta is equal to what? Opposite side by hypotenuse. So sin theta is equal to opposite side means what? PQ by hypotenuse value is equal to OP. Once again see which triangle we consider here. Triangle OPQ will be considered. For the triangle OPQ, O2P will be the hypotenuse. So that sin of I minus r, sin theta is equal to opposite side by hypotenuse value. From this, which value I want to calculate? I want to calculate the value of PQ that will be taken as x. Therefore, PQ is equal to x is equal to OP into sin of I minus r. OP into sin of I minus r. Let it be equation number 1. Equation number 1. Which triangle we consider initially? Triangle OPQ will be taken. From that sin theta is equal to opposite side by hypotenuse. Simple, we will write x is equal to what? OP into sin of I minus r. Again in this equation, OP is the unknown value. OP is the unknown value. Again to calculate the OP value, one more triangle I consider, that is triangle OPR. Triangle OPR will be taken. For calculating which value? OP value. So that from the triangle OPR, I will be calculating the cos R value. Cos R value. Cos theta is equal to what? Adjacent side by hypotenuse. Cos theta is equal to adjacent side OR by OP. Adjacent side, that is what? OR. Hypotenuse is equal to what? OP. What is the OR? OR value is nothing but a thickness of the glass slab. OR value is nothing but what? Thickness of the glass slab. Therefore, here cos R is equal to OR is equal to T by OP. So, from this I need the value of OP. OP is equal to T by cos R. OP value is equal to what? T by cos R. Therefore, from the equation 1 comma equation 2, I am writing the lateral shift value. Therefore, lateral shift is equal to lateral shift x is equal to what is the OP value? T by cos R into sin of I minus R. So, this is the standard equation, standard expression for the lateral shift. What is the formula for the lateral shift? Lateral shift x is equal to what? T by cos R into sin of T by cos R into sin of I minus R. So, this is the general formula for the lateral shift. Now, we will discuss some of the cases of lateral shift. What is the equation you got for the lateral shift? You got that x is equal to T by cos R into sin of I minus R. Now, I am assuming that, so if whatever the angles we consider in the given diagram, that angles will be considered as the small angles. So that for the smaller angles, sin I value will be taken as I. For the smaller angle, sin theta is equal to theta and sin theta is equal to what? Tan theta. So, whenever the angles will be smaller, sin theta value becomes to what? Theta. So, that here I am taking that sin I value is equal to I and sin R value is equal to R. Sin R is equal to what? R and cos R value is equal to 1. For the smaller angles for the cos theta value becomes to what? 1. For the smaller angles, the cos theta value is equal to what? 1. Again, here one more term will be there. Sin of I minus R is equal to I minus R. So, this is the assumptions I consider. Whenever the angle of incidence comma angle of refraction values are the smaller angles, so I am taking that sin I is equal to I, sin R is equal to R, cos R value 1, sin of I minus R value is equal to what? I minus R. Now, that equation can be converted as T by, what is the cos R value we assumed for the small angles? For the small angles, cos R value is equal to 1. Cos R value is equal to 1. Next, here sin of I minus R there. Sin of I minus R value is equal to what? I minus R. So that for the smaller angles, the lateral shift becomes x is equal to t into I minus r, From this again, t into, I am taking the common of I. From this I am taking which value as a common? I. So that the remaining term becomes to what? 1 minus r by I. Again I am writing here t into I, 1 minus. For the smaller angles, r value becomes to once again sin r. I am taking what? R value will be taken as once again sin r, 1 minus sin r by sin I. 1 minus sin r by sin I. So this value can be written as t into I into 1 minus 1 by sin I by sin r. So that value becomes to what? Sin I by sin r is equal to what? Whenever the refraction takes place from rarer medium to the denser medium, sin I by sin r value is equal to mu according to the Snell's law of the refraction. Therefore, x is equal to t into I into 1 minus 1 by mu. X is equal to what? T into I into 1 minus 1 by mu. That is the another expression for the lateral shift in terms of angle of incidence as well as the refractive index of the given glass slab. So this is about the concept of the lateral shift. Is examples of the refraction. In these examples of the refraction, first we are going to discuss about the what? Oval shape of the sun. When we find usually the oval shape of the sun means early in the morning and in the evening sessions. And at what times we are finding the oval shape of the sun means what? In the morning and evening sessions. Why in the morning and evening sessions means in the morning as well as the evening sessions. So this is the horizontal level. The sun will be closer to the horizontal level. In the morning and evening sessions, the sun will be closer to the horizontal level. So whenever the sun will be closer to the horizontal level, whatever the sunlight rays are emitted by the sun surface, they will be traveling through the atmosphere. The light rays which are emitted by the sun surface, they will be traveling through what? Earth atmosphere, and finally they will be reaching an observer who was placed on the earth surface. But while these light rays are traveling through the atmosphere, they undergoes different refractions. Different refractions in a different layers of the atmosphere. So the reason is what? Whenever the light rays are traveling from sun surface to the earth surface, the sunlight rays are undergoing different refractions in different layers. Why the different refractions takes place in a different layers means nearer to the earth surface, the refractive index of the atmosphere will be the maximum. While you are moving away from the earth surface, the refractive index value of atmosphere will be changes. Because of that, different earth atmospheres will be having different refractive indices, so that whatever the light rays are traveling through these layers of the atmosphere, they are undergoing different refractions. As a result, we feel that because we are receiving the different refracted light rays, that means we are receiving the light rays from the different spots of the surface of the sun, so that because of you are getting different light rays due to the different refractions which takes place in the earth atmosphere, as a result the sun will be appears the sun will be appears in the oval shape. So this is the main reason for the appearance of the sun in the oval shape. What is the reason? Due to the change in refractive indices, of the earth atmosphere, the light rays are undergoing different refractions. These different refracted light rays are received by the observer, so that he feels that sun becomes wider at the center and flat at the top, so that he feels that sun will be appears in the form of a oval shape. So this is the reason behind the oval shape of the sun. So what? Visibility of two images of a single object. Visibility of two images of a single object. How it is possible? See, when we find the image, whenever any refracted light ray will be entered into your human eye, that will be giving one image. If two refracted light rays are came, that will be giving two images. If three diffracted light rays are coming, that will be giving what? Three different images. When you find different refracted light rays, those different refracted light rays are giving the different images. This point we have to keep in mind. Different refracted light rays are giving the different types of the images. So here I consider only one of the object. I consider what? Only one of the object. That object will be kept inside the glass cube. So here I consider a glass cube is considered, a glass container is considered. Within the glass container, I place the object. Now, so a liquid of refractive index, which is different from the refractive index of the glass. So if you consider the glass, the refractive index of the glass will be taken as a mu1, and into that glass vessel we poured another liquid which is having the refractive index of mu2. So that refractive index of the liquid as well as the refractive index of the glass are different. So whenever you fill the liquid completely, and then after, if you look at normal towards the given object, then you find two different images. Why it is happened means, here the two different refracted light rays are coming to your human eye. Whenever you are looking towards the object, your eye will be receiving the two different refracted light rays. One of the refracted light ray will be due to the glass medium, and the another refracted light ray will be due to the another liquid. Find here two different refracted light rays. Here you find two different refracted light rays. One of the refracted light ray will be due to the glass medium, and the another refracted light ray will be due to the liquid which is filled within the given vessel. So that your eye will be detecting the two different refracted light rays, so that you feel that you are observing the two different images. So this is due to multiple refraction. Whenever the light rays are traveling through different medium, they will be undergoing the different refractions. So that here we feel that two images will be given for a single object. So this is the second application. What? Twinkling of the stars. So what is the reason behind the twinkling of the stars means? The reason behind the twinkling of the stars is what? Irregular refraction that takes place within the atmosphere. The reason behind the twinkling of the stars is what? Irregular refraction that takes place within the atmosphere. Again, what is the reason behind the irregular refraction that takes place within the atmosphere means, within the atmosphere, the refractive index of the atmosphere will be changes continuously. What is the reason behind that? The refractive index of the atmosphere will be changes continuously. As a result, this type of irregular refraction will be takes place. So because of that, sometimes the refracted light rays are entered onto the earth surface. Sometimes these refracted light rays does not entered onto the earth surface. Because of this reason, we feel that these stars are twinkling. But actually, stars are what? Self-luminous objects. They will be releasing the light continuously, but due to the change in the refractive index of the given atmosphere, these light rays are undergoing the irregular refraction. As a result, we may feel that these stars are twinkling. So this is the another application of the refraction of the light. Next concept, critical angle and total internal reflection. Critical angle and total internal reflection. When the critical angle and the total internal reflection will be takes place means whenever the light rays are coming from the denser medium to rarer medium, whenever the light rays are traveling from where to where, denser medium to the rarer medium, we find the phenomena of the critical angle as well as the total internal reflection. So that to explain the concept of the critical angle as well as the total internal reflection, we consider the two different medium. One is a what, a denser medium, another one is a what, rarer medium. So this is the interface which is separating the denser medium as well as the rarer medium. To explain the concept of the critical angle as well as the total internal reflection, so here I consider the point object O which is placed within the denser medium. Which type of object we consider here? Point object will be considered, that point object will be kept at a point O within the denser medium. Whenever you consider the point object, from this point object, the light rays are emitted out, in a different directions. From the point object, infinite number of light rays are emitted out. So among the infinite number of emitted light rays, I consider the first light ray. The light rays are which is emitted by the given object. The light rays which are emitted by the given object will be incidenting normally on the refracting surface. Already we know that whenever the incidental light rays are incident along the normal, incident through the normal, that a light rays does not deviates from its original path. That means there is no refraction takes place when the light rays are incident along their normal. Let N1 is the initial normal which is drawn onto the refracting surface, so that in the first case the incidental light rays are incident along the normal, so that there is no refraction takes place. As a result, the refracted light rays are passing through the same normal. This is the first case. In the second case, I consider the second normal N2. From the same object, again I consider the second incident light ray. This second incident light ray will be incident, let be the point A. So the second light ray which is coming from the given object will be incident at the point A with the initial angle of incidence which is taken as I1. So in the second case, what we are assuming, so one light ray will be coming out from the given object. That light ray will be incident on this refracting surface at the point A. So whenever some non-zero angle of incidence will be there, the light ray will be undergoing the refraction. So this is assuming as the first refracted light ray, and the angle of refraction value is equal to R1. R1. Now what we are saying, we will consider the another normal, let it be the N3. Again we are taking one more incident light ray. If you observe from here to here, the angle of incidence value will be increases. That means what we are doing here, we are increasing the angle of incidence value in the denser medium. What we are doing here, we are increasing the angle of incidence value in the denser medium. Whenever you are increasing the angle of incidence value in the denser medium, the corresponding angle of refraction is also increases. Whenever you are increasing the angle of incidence value in the denser medium, the corresponding angle of refraction which was existed in the rarer medium, that is also increases. Why? already we know that whenever the light rays are coming from the denser medium to the rarer medium, the refracted light rays are traveling away from the normal. The refracted light rays are bending away from the normal. So that if you increase the angle of incidence value, the corresponding angle of refraction value is also increases. So like that, continuously by increasing the angle of incidence, we will also find the angle of refraction value will be increases. But at a particular angle of incidence, within the denser medium, for a particular angle of incidence within the denser medium, the refracted light ray will grazes the surface. For a particular angle of incidence, within the denser medium, whatever the refracted light ray will be existed within the rarer medium, that refracted light ray will be just grazes the refracting surface. That particular angle of incidence value which was present within the denser medium, will be calling as critical angle. So how can we define the critical angle? The angle of incidence in the denser medium, for which the refracted light ray just grazes the refracting surface. Such a type of angle of incidence which was existed in the denser medium will be calling as critical angle. So that here the critical angle will be represented by capital C. So that here the angle of incidence I0 value will be equal to what? Critical angle. At that angle of incidence only, the refracted light ray will be just grazes the surface. Here the refracted light ray will be just grazes the surface means with respect to the normal, how much angle it was doing? So that the angle made by the refracted light ray with respect to the normal is nothing but 90 degrees. So that at the angle of incidence value is equal to C, at the angle of incidence I0 value is equal to C, the angle of refraction value is equal to what? 90 degrees. So that if the angle of incidence value will be saying as the critical angle, the corresponding angle of refraction is equal to what? 90 degrees. So such a type of angle of incidence we are calling as a what? Critical angle. So what is the definition of the critical angle? The angle of incidence in the denser medium, for which the refracted light ray just grazes the refracting surface. Such angle of incidence will be calling as a what? Critical angle. So it is denoted by capital C. When you find the critical angle, what is the condition is required means the light ray travels from where to where? Denser medium to the rarer medium only. In which condition you find the critical angle means important one, the light ray must be traveling from where to where? Denser medium to the rarer medium. So that is the concept of the critical angle. Total internal reflection. Just now only we discussed that Whenever the light is traveling from the denser medium to the rarer medium, whenever the light rays are traveling from which medium to which medium? Denser medium to the rarer medium. At a particular angle of incidence, what we observed at a particular angle of incidence, that is nothing but critical angle, the refracted light ray will be just grazes the surface, when it is possible, if the angle of incidence value is equal to critical angle. If the angle of incidence value is equal to what? Critical angle, the refracted light ray will be just grazes the surface. Suppose, if we are assuming that within the denser medium, if the angle of incidence value will be greater than the critical angle. Suppose initially we assumed that the critical angle will be is equal to 40 degrees. In this case, what we did, if the light was incident on the interface at a 41 degrees, that is, the angle of incidence value will be greater than the critical angle. At that instant, if the light was incident with the angle of incidence which is greater than critical angle, there is no refractor ray was present within the rarer medium. We can't find any refracted ray that was present within the rarer medium. Then what happens? Whenever the light is incident with the angle of incidence that is greater than the critical angle value, there is no refraction will be existing. Whatever the light will be incident at this interface, that a light ray will be completely reflected back. The light ray will be completely reflected back within the same medium. Such a phenomena will be calling as total internal reflection. Once again, when the total internal reflection will be takes place means, whenever the light rays are traveling from the denser medium to the rarer medium, and moreover, if the angle of incidence in the denser medium, will be greater than the critical angle, we can't find any refractor ray in the rarer medium. Whatever the incident light was incident, that incidental light will be completely reflected back within the same medium. Such a phenomena we are calling as a what? Total internal reflection. So what are the conditions are required for the total internal reflections means? First one is what? The light rays are traveling from where to where? The light rays are traveling from the denser medium to the rarer medium. So the incidental light ray will be present within the which medium? The incidental light rays must be present within the denser medium, and they will be traveling from which medium to which medium? Denser medium to the rarer medium. And the second condition is required for the total internal reflection means, so the angle of incidence within the denser medium will be greater than the critical angle. So in that case, the light rays are completely reflected back within the same medium. Such a phenomena we are calling as a what? Total internal reflection. So this is the concept of critical angle as well as the total internal reflection. Now, next one, we are going to derive an important relation, that is nothing but mu is equal to 1 by sin c. Mu is equal to what? 1 by sin c, or it is also calling as relation between refractive index and critical angle. Relation between the refractive index and critical angle. Sometimes they are asking derive the relation between the refractive index as well as the critical angle. For that, I consider the Snell's law of refraction. Which law of refraction? Snell's law of refraction. What is the Snell's law of refraction formula? Already we know that Snell's law means always we have to write mu1 sin I is equal to mu2 sin R. Snell's law general formula is what? Mu1 sin I is equal to mu2 sin R. So mu1 in generally where we consider where the incidental light was present, that medium will be taken as the first medium, and mu2 will be taken where the refracted light or reflected light will be present, that medium will be taken as the what? Refractive index of mu2. So initially whenever we are discussing the critical angle concept or total internal reflection concept, incidental light rays are present within the which medium? The incidental light rays are present within the denser medium. So that the first medium will be taken as a what? First medium will be taken as denser medium. First medium will be taken as a what? Denser medium. For the denser medium, refractive index value is equal to what? Mu1 is equal to mu. For the denser medium, refractive index value is equal to what? Mu1 is equal to mu. Next. Here we are assuming that the light rays are incident at a critical angle. The light rays are incident at critical angle. So whenever the light rays are incident at a critical angle, so angle of incidence value is equal to what? Critical angle. Now we consider the second medium. Which medium we consider the second medium? Rarer medium or air medium. For the rarer medium, the refractive index value is equal to 1. For the rarer medium, refractive index is equal to what? 1. And in the rarer medium, angle of refraction value is equal to 90. Already we told, whenever the incident angle is equal to C, the refracted light ray will be just grazes the surface. As a result, angle of refraction value is equal to what? 90 degrees. That only we taken. For the second medium, rarer medium, mu2 value is equal to 1, angle of refraction is equal to what? 90 degrees. Now you substitute all these values in that above equation. Mu1 is equal to what? Mu into sin C is equal to mu into sin C is equal to what is the value of mu2? That value is 1, and sin R. Sin R means what? Sin 90 degrees. Therefore mu into sin C is equal to what? 1. Therefore mu is equal to 1 by sin C. Mu is equal to what? 1 by sin C. So this is the relation in between the refractive index and critical angle. Refractive index and critical angle. Here we are going to calculate angle of deviation when the incidental light in the denser medium was incident with the critical angle. The incident light ray which was incidenting with what angle? Critical angle. So see here, I consider here the light rays are coming from where to where? Denser medium to the rarer medium. The light rays are coming from where to where? Denser medium to the rarer medium. So if there is no another medium was present here, the light rays are traveling like this. Okay. So here, because of they will be traveling from the denser medium to the rarer medium, so the light rays are bending away from the normal. So if I am assuming that the incident angle value will be taken as I is equal to C. I is equal to what? C. That means the light rays are incident within the denser medium with the critical angle. Whenever the light rays are incident with the critical angle, the refracted light ray will be just grazes the surface. So the angle between the incidental light ray and refracted light ray will be taken as a what? Angle of deviation. What is the definition of the angle of deviation? Angle of deviation is the angle between the incident light ray as well as the refracted light ray. So here the refraction will be takes place from which medium to the which medium? Denser medium to the rarer medium. Whenever the refraction was takes place from denser medium to the rarer medium, angle of deviation value is equal to, already we know that angle of deviation is equal to angle of refraction minus angle of incidence. In this particular case, whenever the angle of incidence value is equal to critical angle, whenever the angle of incidence is equal to what? Critical angle, the angle of refraction value is equal to what? R is equal to pi by 2. R is equal to what? Pi by 2. Therefore, the angle of deviation will be given by delta is equal to R is equal to what? Pi by 2 minus. What is the angle of incidence in this case? The angle of incidence value in this case is equal to what? Critical angle. Therefore, delta is equal to what? pi by 2 minus c. Delta is equal to what? Pi by 2 minus c. So this is the expression for angle of deviation whenever the light will be incident with the critical angle. So delta is equal to what? Pi by 2 minus c. So this is the concept of what? Total internal reflection as well as the critical angle. In the next class we will discuss the applications of the critical angle and total internal reflection.